projectors, biophotonics, the list goes on, and I don't need to tell you about it, but there's a theme, and the theme is make it smaller, make it fastable, and make it switchable, okay? And if you can do that with photons, you have a lot of power to do this. So, you know, the research that I do with students is really about finding the best properties of organic materials, which can be merged with electronic materials so that you can use light to change the electronic distribution of organic materials and then use that to switch electronic flow. So it's a very exciting field, and we work with a variety of different types of scientists, chemists, materials scientists, engineers, physicists. It's a broad field. And that's what students from Beuth will work on when they come to my laboratory. So I'll give you a quick overview of what this is really about. Electric field, or of a light wave, for example, as you know, is essentially a force field which alternates this direction then this direction. And if it encounters a material, it will then cause that material, the electrons in that material, to stretch likewise back and forth. And we call that the polarization of the material. So when light hits something, it polarizes it very fast back and forth. And so it should make sense that the stretching is proportional to how strong the light is. More light, more stretch. And we call that a linear material. And you know that from everyday optics. That's where the index of refraction comes from. And everything you see in everyday life, diffraction, refraction, birefringence, all of these things originate from this idea that electrons can be pulled away from their atoms very slightly when a light wave moves through them. So this is the basis of a huge technology revolution. Even though it's old, if you want to think of it that way, optics. It's traditional, conventional optics. And so, but things also get interesting if you have materials that are that respond to light in what we call a nonlinear way. Additional terms there give rise to these things, nonlinear optics, which is now becoming very exciting because we have lasers that can do this, and we can engineer organic materials which stretch a lot when a light wave passes through them. So this is where you get green lasers and blue lasers, and our ability to make one color of light from another color of light. So it's also the basis behind an effect called the electro-optic effect, which is the background of all internet communication. Are materials like this that can convert light into different colors and convert voltages into light signals. So it's a very exciting area that you would be in, and it's all electrodynamics and electromagnetism and a little bit of chemistry. So it's physics that you can understand, which is why I like doing it, because I can understand it. So what are the sorts of practical things that the students work on in my lab? Well, what we're most interested in is materials that you can switch back and forth between linear and nonlinear with light. And so students learn how to use lasers. They learn how to work with holography, which Professor Eisler is an expert in. They learn how to convert colors with harmonic generation. And then there's practical skills, electronics, photon counting, software. You learn how to use LabVIEW to make experiments work. And the best part, you know about LabVIEW? I don't like it, but I have to use it because it's taking over the world, unfortunately, in the lab. But the nice part about working in our laboratory is we're a small university. So when you come, I give you a key, I show you the lab, and you begin working with our students. There aren't graduate students there. You don't have to get in line behind 100 other people. It's your opportunity and your laboratory. So it's a great chance to be able to work independently. So I'll give you an example of what the last year's student, Alyosha Fati, did. He spent a year in 9 months in my laboratory, and his project was we had a material that was developed by one of my collaborators at the University of Wisconsin and at Johns Hopkins University that when you irradiate it with blue light, you can cause this organic dye molecule to change its shape from this to this very quickly. It seems like a simple idea, but by doing that, you redistribute the electrons in a controllable way. So Alyosha designed this experiment. He built the experiment on the right, which is really a very simple experiment, but to measure the kinds of signals, they were very weak signals. That's where a lot of the work came in. But he built this completely from nothing in the laboratory, where he worked with a blue laser to light up this material, and then with a separate laser, a red laser, which had a very well-defined electric field direction, he could determine if the molecule was indeed switching back and forth. And so he, some simple data that he came up with. This graph I just put up shows essentially the ability of the material to pass red light in response to the blue light. So he turns the blue laser on, red light goes through, he turns the blue laser off, and what happens is the signal decays. And this was the basis of a very large project, which he then involved. He extended it by storing images, which are a series of changes in the molecule over the surface of the material. We can talk a lot more about that, about the details, but the point is he was the owner of this project and developed this original data and built the entire experiment and then wrote his thesis. And that kind of project is what all of these students have done over the past several years. They've all done outstanding work, and most recently, like I said, Alyosha has found himself in Munich with a very good job. So it's a good opportunity to do this. And if you do pursue this opportunity, because we're a small university, we work with other universities which are larger. So we work with a major research university, the University of Wisconsin and Johns Hopkins University, and we can offer you some money. That's always a good thing, right? We can offer you some money to live. Okay, we would hope that you would look at DAAD, which I don't know, would they know?
DAAD kennen Sie wahrscheinlich. Deutscher Akademischer Austauschdienst für Stipendien.
And I believe 2 of those students had DAAD, or at least 3 had DAAD funding. But we can also offer you enough to live, meaning a small apartment or a dormitory room while you're there. So it's because we have funding from the United States government for this work. So let me tell you a little bit about the university. It's always good to see what you're getting into. The College of New Jersey is what we call an undergraduate institution, which does not offer the PhD. So it's very similar to Beuth, I believe, and in many ways. The only difference is that we are suburban, meaning we are put down in the middle of lots of trees, and the city is a little bit. You can get to the city easily, but it is a suburban university. But it's a very beautiful university. As you know, New Jersey is very central on the East Coast. We are located right in the middle, just outside the capital of Trenton. So it is an excellent location. Thank you. Right in the middle. You are 40 miles from the ocean. You are 20 miles from Philadelphia and maybe 60, 70 miles from New York City. And there's a train that goes right through the outside of campus, so you can get anywhere you need to go very easily. So it's really the perfect location because of that. So we have 7,000 students. We have a good physics department, about 100 physics majors. So people just like you are in our department. And we have programs in physics, biophysics, biomedical physics, and also electrical, biomedical, and mechanical engineering. So you'll get to interact with a lot of students who are studying these fields. again, we have a very helpful international office that is really excited about having more students come from other countries. And so I think every year we have 10 visiting students from Germany, among other countries. And the director of our international office is German, so that's also a good thing. So and he did his PhD in Frankfurt.
Oh.
So you have a special connection there. And it's a very friendly department. You know, we do things. In fact, those are the last 3 Beuth students getting together, coming back to visit our department for our spring semester picnic. And I guess the other thing I'll say is we have very nice laboratory facilities. So, and you'll work with our students. So the upper right-hand corner, that's Daniel and Uli, who were here 2 years ago with our students in the laboratory that they use. And I think the best thing about this is because we're somewhat of a different undergraduate school, meaning that the state has given us the mission to do research with undergraduate students, which is not usual for most colleges in the United States. Usually they just teach. But we are lucky in that we work with our students, just like you, in the laboratory. And so if you come, you'll be part of a team with our students. It won't be like you're here and they're there. You're all together. And I think that helps my students a lot. They've made good friendships. And it helps you, obviously, if you want to practice your language skills or make friends in another country. I think it's a great thing to do. And you're part of the department, too. You can take classes. You can. The last few students we had, I couldn't tell the difference from them from other students at our university. And the building, it's a relatively new science building, so we have an observatory, great facilities. So I would encourage you to think about this. And last but not least, you can start. It's a very flexible starting date. In other words, some students come in October, some come in June. It's up to you, whatever we can work that out. And like I said, despite what you've heard about the federal budget in the United States, it got turned back on again. So we do have some financial assistance we can offer. And if we don't use it, it goes away. So you have to think about coming and helping us use some of this financial assistance. So there's my email, there's pages, there's the website for the university. But the best part is, I'll be here in April for 3 months teaching a course in holography with Professor Eisler. And so if you don't get your questions answered now, come back and visit me in April. Okay, we'll be great. In fact, we're finally bringing our own students here. So in April, I believe 2 of my students are coming here for 3 months to take this course. So they're going to get a chance to do what you have a chance to do. So do you have any questions about this?
I have a question. One difference is with your colleges, the students pay not to get students. So I only want to see our students are in a very lucky situation. All the other students from the States, they pay for them.
That is a very good point, which I will add that to the next presentation. But, yeah, our students, as you know, or may not know, pay a lot of money for their education, which is unfortunate. And what we call the public institutions that are run by the states, so the University of Pennsylvania, there is no University of New Jersey, it's called New Jersey Com. I don't know why they named them, but there are public and there are private. And the public institutions are generally less expensive, but it's still, relatively speaking, it could be $20,000 US per year at a public institution for and it goes up to $50,000 for a private institution. So students, but for you it's free. Okay, so that is a very good benefit to have. I have not figured out why more of our students haven't come to Europe to get, because it's going to come to that, I think.
But if you go to study in the United States for yourself, you have to pay 20,000.
Yeah.
If you go with him, you pay nothing.
Right. Now you're not there for 4 years, but you come for 1 year.
Yes.
1 year, 9 months, and you get to do your thesis. And you get to take classes, and you can take as many classes as you want, and there will be no charge. So but yeah.